All right, next up, we're going to talk about acidic and basic solutions. So you've probably heard or used this terminology yourself. Oh, this is really acidic. This is, whatever. But do you really understand what it means? And so generally when we're talking about, how acidic or basic a solution is, we're talking about its pH. And we'll touch on that a little bit later. But first, we're going to kind of go back to the reasoning of pH. So what is pH measuring? Well, we just learned that acids were basically H plus versus hydroxide. And so pH is just a measure of how much H plus you have versus how much hydroxide you have, right? H plus, the ratio of H plus to hydroxide. And so our first question is, what happens in pure water? And so as we've seen in the previous examples, water can act as an acid or a base. Right? We saw examples where water was an acid. We saw examples where water was a base. And this is called amphiprotic or amphoteric. And since water can act as an acid or a base, it can actually react with itself. And this is called autoionization. Right? Because it's ionizing itself. So, for example, when we have water, which is a liquid, reacting with another water, which is obviously still a liquid, they can autoionize one another, right? So one can donate an H plus and one can accept an H plus. So we would form H3O plus and hydroxide, right? That's how it would autoionize. One thing to note that you should really kind of understand and accept is that H plus and H3O plus are the same thing. When everyone says H plus, they mean H3O plus, assuming you're working in an aqueous solution, right? So in this course, H plus and H3O plus can essentially be used interchangeably because the vast majority of time we're going to be talking about water. And so we have an equilibrium here, right? We've got an equilibrium here. And so we can write a value of K, an equilibrium constant. And so this K gets a special subscript. It gets a KW. The W stands for water. And remember, K is a measure of reactants over products. However, we ignore liquids, right? And both of our reactants are indeed liquids. So it's just going to be the products multiplied by each other, right? So it's the concentration of H3O plus or H plus and hydroxide, right? And they're all both to the coefficient of 1 because their coefficients are 1. And so at 25 degrees Celsius, which is kind of standard room temperature, this value comes out to be 1.0 times 10 to the negative 14. And so KW will always equal 1.0 times 10 to the negative 14. It doesn't matter how much acid, how much base you add, the KW is a constant. It will always be that constant at 25 degrees Celsius. It is an endothermic process. So heat is a reactant. So when we increase the temperature, we actually increase the amount of products. And since KW is the products multiplied by themselves, KW is going to increase. So for example, at 100 degrees Celsius, your KW actually increases to 5.6 times 10 to the negative 13. However, you'll very rarely see anyone mention water's KW as anything other than 1.0 times 10 to the negative 14. Even though it does technically change, you won't see it really be used other than 1.0 times 10 to the negative 14. All right, and then the other thing that we know is that since all the H3O plus and hydroxide in pure water comes from water, right? If we take a look at this reaction, for every one of these that you form, you have to form one of these. So their concentrations in pure water have to be equal. And so the concentration of H3O plus has to equal the concentration of hydroxide, and they multiplied by them or by each other have to equal 1.0 times 10 to the negative 14. So in pure water, you have both of these concentrations are equal to 1.0 times 10 to the negative 7. And we'll see why this number gets important later on. And so when we say a solution is acidic versus neutral versus basic, what we're talking about here is the ratio of H plus or H3O plus to hydroxide. So when we say a solution is acidic, that means that we have more H plus than hydroxide. When we say a solution is neutral, such as that in pure water, we say that the concentration of H plus is equal to the concentration of hydroxide. And then when we say a solution is basic, we say that we have less H plus than hydroxide.